Hi everyone, John here talking about lines, section 1.2 in your book. This section should be mostly review, so I'm going to try to go through this quickly, but remember that you can always pause, you can rewind, you can rewatch this as many times as you want. So the first thing I want to talk about is slope. Slope is a word that can only be used when describing a line. The slope is the rate at which the line changes, and because that rate of change is constant, it gets the special name slope. To calculate this slope, we do the change in the y values over the change in the x values, also known as the rise over the run. Now, what can be confusing is that coordinates are x comma y, but slope is y over x. It's the change in the y over the change in the x. So just keep that in mind as we move forward. So we're going to calculate the slope of a line that passes through these 2 points. So it doesn't matter which point is point number 1 and which point is point number 2, just as long as you stay consistent. If this is x1, then this has to be y1. And if this is x2, this has to be y2. The points stick together, okay? They're ordered pairs, the order matters, and the grouping of them matters. So the change in the y is going to be 3 minus -1. That's y2 minus y1 over the change in the x, which is 3 minus 1. So in the numerator, we have 3 minus -1, which is 4. In the denominator, we have 3 minus 1, which is 2. And so the slope of the line that passes through these 2 points is 2. Again, it's the slope of the line. It's not the slope between the 2 points. It's the slope of the line that passes through the 2 points. All right, moving on to the next one. That last example, we had a slope of 2, which is a positive number. Positive slopes rise from left to right. Slopes with negative slopes, or lines with negative slopes, fall from left to right. And we read graphs just like we read books, from left to right. So we start as far left as we can see on the graph, and then we move to the right as we read the graph. The greater the absolute value of the slope, the steeper the line. A slope of 9 would be super steep, okay? A slope of -9 would be just as steep, just in the downward direction. The slope of a vertical line is undefined. If we are changing the y values, so we're changing y distance over no x distance at all, we are dividing by 0 when we try to calculate this slope. And so the slope is undefined, and we would actually write the word undefined to describe that slope. The slope of a vertical line is undefined. The slope of a horizontal line, we are moving across distances in the x direction, but no vertical change is happening, and so there is 0 change over a change in x distance, and so we are getting 0 slope, okay? And there is a big difference between 0 as a number and undefined as a description. So just make sure you're keeping that in mind. Point slope form of a line. I can't say enough good things about point slope form, okay? If you go on to take calculus, this is going to be the main way that you deal with lines using point slope. Now, the reason this is convenient is because when you take calculus, the slope is something you're going to calculate using calculus, and the point is something you're going to calculate using algebra. And so because you will almost always have a point and a slope, writing an equation in point slope form is just natural, because if you know the point and the slope, it's really easy to write the equation. I think a lot of people steer clear of point slope form because they can't remember the formula, but I'm just going to show you a little trick real quick so that you remember this. And we know the slope formula is y2 minus y1 over x2 minus x1. I'm going to multiply both sides of this equation by x2 minus x1. So I'm essentially moving this from the denominator and putting it over here. That leaves me with y2 minus y1 equals m times x2 minus x1. If we just stop writing the subscript here for y2 and for x2, you can see we have the point slope formula. So you don't have to, it's not something new to memorize. It's basically just the formula for slope. We just moved the denominator of the slope over to the other side next to the m. Now the reason this is so easy, if we know the slope is 3 and that there's a point 1, negative 2, y minus negative 2 equals 3 times x minus 1. Here's my y1, here's my x1. So this is really y plus 2 equals 3 times x minus 1. And I found the equation very quickly. 2 steps. Okay, even if I wanted to put this in slope-intercept form, I could easily do that by distributing the 3 and then subtracting 2. And then we're going to find the equation of the line that passes through the points negative 2, 1, and 3, 7. First, I have to find the slope. So the change in y over the change in x. This is my slope. I can take either one of these points, 3, 7, or negative 2, 1. I'm actually going to do them both, just so you can see that we're going to get the same line either way. They might not look the same at first. So we have y minus 7 equals 6/5 times x minus 3. Or we have y minus 1 equals 6/5 times x plus 2. But if you distribute the 6/5, and this is why people like slope-intercept form, because you'll always get the same answer no matter which way you do it. So we have y minus 7 equals 6/5 x, and now when I distribute, I just distributed it there. If I distribute it to the negative 3, I get negative 18/5. Okay, now instead of writing this 7 as a 7, 7 is 35/5. So when I add this, I'm doing negative 18 plus 35. And that gives me 17/5. So now let's look over at this other example. If I distribute the 6/5, I get 6/5 x plus 12/5. Fifths is hard to say. And so that makes this a 5/5. 1 is 5 over 5. So then y is equal to 6/5 x plus another 5/5 on top of the 12/5 gives me 17/5. So these are the same equation, okay? And notice how when I had it in point slope form, I didn't have to worry about slope, like all these fractions adding and subtracting. Point slope form is going to become your go-to when you get to calculus. Okay? But for now, if you're comfortable with slope-intercept form, it's fine. That's what we're going to talk about in the next video. I'll see you in the next video.